seconds, and then another gap of 9.6 seconds. And that's what gives us those huge gaps on the chart. But I still want to look for those big gaps around 640 seconds in the trace. Wow, they must have happened very fast there because I was just barely scrolling. Ow, look at that. Look at that. 9.5 second delay between this packet right here and this retransmission that went out on the wire, and then almost a 20-second delay until the next packet went out on the wire. So I really like setting up both the time column that'll show me the time from the beginning of the trace and the delta time columns. So let me show you what that looks like in my preferences setting. I'll select Edit, Preferences, and here we go. In the columns area under User Interface. But there's my time, and it's set up as time format as specified, which means I went up under View, Time Display Format, and set it as time since the beginning of the capture. But there is a specific format that you can use called Delta Time. So I gave it the title of Delta Time. I clicked New first, then gave it the title of Delta Time, and then in this format area there I selected the Delta Time option, and that's what created that one. Remember that if you go in and you add columns to Wireshark, you're going to have to restart it. I'd like to show you now where you can get those field values that I was showing you. The field values such as TCP dot analysis dot lost underscore segment or TCP dot analysis dot retransmission. I'm on the Wireshark homepage, and I'll select Documentation. And in the Documentation section, you'll see that it says Display Filter Reference, and that's where you want to go. So I'll click on Complete List of Display Filters. I'll scroll down to the index line, and here I'm interested in building some TCP display filters that I'll use in my I/O graph. So I'll click the letter T, and here you can see TCP listed there, so I'll select Transmission Control Protocol. And now as I scroll down, here are all of the values that I can use. There you can see there's my TCP analysis duplicate ACK line, and if I scroll a little bit further, there's TCP analysis lost segment, retransmissions. There's the timeout value. There's the TCP analysis window full. And remember, TCP analysis, those are the ones you do with the count calculation. So you want to count the number of times the window is full. You want to count the number of window updates. You want to count how many times there's a zero window. If I scroll further, you'll see here are the TCP fields, the individual fields in the TCP header. So the flags field. We'll scroll down a little bit more. The length field, there it is. So that's one where we can add it up, the value that's in the TCP length field. Now that's a segment length. That's not the header length. That's actually the segment length. And as I scroll down to the bottom, that's where you'll see TCP dot window size. So if you wanted to see what the window size was in a communication and have it plot it for you, you could tell it to go ahead and use sum with the window size. So add up the window size as you go through. So this is where you can find some of that information. As you saw before, another place you can go is you can go into the actual frames themselves and look at some of these time values. So I selected the time delta from the previous packet. In addition, some of the TCP packets will have some additional information in them. When we see this sequence and acknowledgement analysis, this one right here where we see the round trip time to ACK the segment was, you can right mouse click on that, say you want to prepare a filter based on the selected value. Preparing a filter isn't going to apply it. It's just going to let us see what the syntax would be. And now we know the syntax for plotting out the TCP analysis ACK round trip time. In Wireshark, to get the most out of TCP time sequence graphs, you really have to have a good understanding of TCP/IP communications. Because Wireshark is going to use the sequence number field values, and I'll open up a packet here, and let's go inside. There's there's a sequence number value, but it's a relative sequence number value. In other words, Wireshark is trying to make it easier for us by doing a starting sequence number of 0. Now, we're also going to use the acknowledgement number field value to put packets in order, in the order in which they were received, the order in which they should be received, and the TCP/IP communication set, TCP, uses those sequence number and acknowledgement number fields to tell the other side which packet it expects next. And this is the way we can find packets that are out of order, packets that are missing, and this is the way we send duplicate acknowledgments to say we're missing this sequence number, we're missing this sequence number. Under Statistics, I'm going to select TCP Stream Graph. And because of the resolution that I'm recording on, you're not going to be able to see all the graph listing here. Unfortunately, the last two graphs are the time sequence graph and the time sequence graph for Stevens and the time sequence graph for TCP trace. And I'm going to look at the Stevens graph first. It's pretty recognizable because it's just a series of dots. Now I'm going to move this graph over so you can see a little more about it. But if you look in the upper left-hand corner of the graph, first of all, let's focus up there. You'll see that it's telling us that the y-axis is the sequence number value. And it also tells us what the trace is we're looking at and the direction of flow of traffic. If you were just looking at the side of communications where somebody's sending acknowledgments over to the other side, this would be a very boring graph and you wouldn't see anything because the sequence numbers are not going to start counting up. Those sequence numbers count up as data is transferred across the cabling system. So if it's just a really boring graph, close it down, you pick the wrong side of the communication. Now I'm going to bring this graph up a bit so you can see the bottom of it. And the bottom of it is our time axis. Across the x-axis is giving us time. Now if we look at the trace and we have the trace time value set to show us the time a packet arrives compared to the first packet in the trace, we should be able to match these up directly with packets in our trace file. When we look at the time sequence graph, it should have a line going from the lower left-hand corner, gradually going all the way to the upper right-hand corner. We shouldn't see these little plateaus in a file transfer, an unattended file transfer, where you just say FTP this file up to the server and you hit enter and it just goes. It should look like this. So the end of this trace, everything looked like it went really well from about 650 seconds to the end of the trace. And there's a section here where things look like it went all right, but we have a little plateau in there. We don't like to see that. But we can see numerous points where things didn't go well. So here, between 40 and 50 seconds. There it looks like another problem about 125 seconds into the trace, another one about 145 seconds into the trace, another problem about 310 seconds into the trace, let's say. Then we've got another little plateau up here, another one, and all of these things are indications that we have problems. In order to zoom in and see those problems closely, you do a left mouse click, and every time you left mouse click, it'll bring you in closer to those problems that are in the trace. So I'm focusing on, let me pick this one, this area right here. And we'll see what happened here. Let's go right up here. Now here we can look in this trace and we can see that we've got these big areas here where we have gaps of time, and that's certainly not good. And also, these are the packets being transmitted, and the sequence number is steadily going up. If we ever see it drop back down again, we know that that's a retransmission on the cabling system. So as we move closer in here, this little dot would be a retransmission of this dot in the middle of